hard to.
Got me started?
Yeah,
Oh,
just,
sorry.
do you have a bigger one? It's not as loud.
Stop, Ruby. You're making me think about something else. Okay. LCD, least common denominator. You guys know how to do this. If I give you 4 and 8, and I ask you to find the least common denominator. A lot of you would just say 32, because you've learned that I can just multiply them together. That is a common denominator, but it's not the least common denominator. So to find the least common denominator for 4 and 8, obviously, hopefully you're thinking it would be 8. 12 is a common denominator, 24 is a common denominator, but the least common denominator is 8.
8, no, I knew that.
Yeah. So how about when it asks me for the least common denominator of 3/4, 11/30, and 7/45. We did this. Do you guys remember working on least common denominators in the 7th grade? Who hated them? Someone hated them. Oh, he's not with us anymore. That guy. Forget his name. But he hated them. So remember, here's what we need to do. Prime factor. 2 squared. Everybody comfortable? I'm prime factoring the denominator because we're trying to find the least common denominator. So this is going to be 15 times 2, 3 times 5 times 2. That's my prime factor of that guy. Prime factor here, I got 9 times 5, so that's 3 squared times 5. I prime factored everyone. Now, it's the product of the factors, of the greatest factors that occur. Not what they have in common. Doesn't matter what they have in common. It's the ones that occur. I need a big number that 4, 30, and 45 will go into. So I'm not looking for a factor that they have in common. That's not what I'm looking for. It's the product. Product means I have to multiply it together of the greatest factors that occur. So let's see, does 2 occur? It does. And the greatest factor is 2 squared. Does 3 occur? It does. It occurs at least once somewhere. And I want to pick the greatest factor. It's going to be 3 squared. Does 5 occur? It does. The greatest factor would just be a 5. So the product of these numbers is the least common denominator. So that's 4 times 9 times 5. 20, we use the commutative property and do 4 times 5 because that's easier in my brain. 20 times 9. So the LCD is 180. It's a big number that 45 goes into, 30 goes into, and 4 goes into. LCDs. So we prime factored. And it was the product of the greatest factors that occur. Greatest factors that occur. You won't be doing a lot of numbers, obviously, because we dealt with that in the 6th grade. We're going to be working on polynomials to find the LCD. It has the same idea. So let's look. 3 over 6x minus 30 and 8 over 9x minus 45. Let's take a break really quick. Why am I finding LCDs besides to just take your time during the day instead of you being here? Where do you think I'm going with this? Why would I need to find a least common denominator in fractions? Is anyone thinking why I would find a least common denominator in fractions? Lord, it's quiet without Isabella whispering to Jonathan. Very, very quiet, and Ruby left the room too. We're finding least common denominators, and we're dealing with fractions in this chapter. So we're going to be adding fractions, and not just like 1/2 plus 2/3. We're going to be adding polynomial fractions. So that's why we're dealing with polynomials. So we're going to use our ability to factor, because in order to determine the common denominator for these two denominators, right now I'm not adding them, I'm just trying to find the LCD. So we're going to use the same idea. I'm going to factor each of these denominators. See, I told you that factoring thing, not going away. So we're going to factor each of these. You can go further if you want, because obviously 6 is not prime. That would be 2 times 3 times x minus 5. And this is 3 squared times x minus 5. So you prime factor. Now it's the product of the greatest powers that occur. The greatest powers that occur. Does a 3 occur? Yes. What's the greatest power you see? 3 squared. Does a 2 occur? Yes. They don't have it in common. They don't need to. A 2 occurs. Put it up there. Does an x minus 5 occur? It does. So the LCD for this guy is going to be 9 times 2 times x minus 5. 18 times x minus 5. That's my LCD. I took my denominators. I prime factored. Then I use these words, the product of the greatest factors that occur. 3 occurs, I took the greatest. 2 occurs, x minus 5 occurs. Then I did the multiplication of them and got 18 times x minus 5. Let's try another one. Yeah, they get harder, sorry. We'll start easy and slow. Let's try 7 over m plus 2 and m minus 1 over m squared minus 4. So our whole idea is to find the LCD. So all we're doing right now is to find the LCD. So once again, my directions, which are still on the board, we're going to factor. Well, this guy's already factored, m plus 2, he's done. This is the difference of squares, the difference of squares. Mons, you see that? Montserrat, difference of squares. M minus 2 times m plus 2. So I factored it. So now my denominators are both factored. Now it's going to be the product. That means I'm going to multiply things together. The product of the greatest powers of the factors that occur. They do not have to be in common. If it's up here, it's got to be part of the LCD. Does m plus 2 occur? Yes, it does. Both of them have it. That's not a requirement. They don't both have to have it. If it occurs, and obviously the greatest power is just to the first power. Does m minus 2 occur? It does. So the LCD is the product of those two. That's the biggest number that and that will go into, is divisible by. Let's try another one. Uh, 3y over 2y minus 4 and 1 over y squared minus 4. Okay, write the problem down. 3y over 2y minus 4 and 1 over y squared minus 4. I want you to hit stop, but before you do, I want you to factor the denominators for me. Hit stop, factor the denominators. Turn me back on when you have your denominators factored. Okay, hopefully you have 2 times y minus 2 and difference of squares, y minus 2, y plus 2. If you went as far as to tell me what the LCD is, to go all the way to the end, it would be the product of the greatest powers of the factors that occur. Does y minus 2 occur? It does. Does y plus 2 occur? It does. Does the number 2 occur? Yes, right here. Shaylin, all by itself. I'm not talking about that 2 or that 2 or that 2. These are families. These are factors. This guy. So this is your LCD. It's the product of the greatest powers of the factors that occur. Okay. Tonight, we're going to do page 261 in the oral, 1 through 20. 261. And we're going to do written, 1 through 20. Page 261, 1 through 20, written exercises 1 through 20. Okay, my video girl is gone, so I'm going to be walking this way to turn the video off. You guys have a good day. Happy St. Pat's Day. Notice my green. And Miss Ya, wash your hands.